Hello, everybody, and welcome to another episode of What's Up with the Universe. I'm your host, Eli Hugh, and I want to welcome everybody who's joining me today live streaming. If you're not joining me and watching on the rewatch, welcome anyway. If you decided to search YouTube or any other platform to find out what's up with the universe, hey, welcome. If you're new, don't forget to hit that little subscribe button and that little bell. Why the bell? Because you get a notification of when I go live. And if you're unable to watch me live, you can always have a little rewatch and a little program there, a little stream there. So, okay, last week we talked about the moons of Saturn, and we are continuing on our journey of our own little solar system. Today we are talking about, guess what? The moons of Jupiter. Yes, the moons of Jupiter. Jupiter has basically 4 large moons, which were discovered by Galileo in 1610 using a 20-power telescope. These moons are known as the Galilean moons, and they are called Io, Europa, Ganymede, and Callisto. Of course, Jupiter has about 53 named moons and another 26 awaiting official confirmation of names. But scientists think there's now about 79 to 80 moons of Jupiter. I'm going to tell you every single moon that's been discovered so far of Jupiter. Yes, I'm going to take a deep breath on this one. There is Metis, Andrastia, Amathea, Thebe, Io, Europa. There's Ganymede, Callisto, Themisto, Leda, Himalaya. There's also S-2018J1, S-2017J4. There's Listia, Alera, Dia, Carpo, Valetudo. There's S-2003J12. Europori, not Europa, Europori. There's S-2003J13, J18, J2. There is Thelzone, which is spelled Thelxione, Thelzone. There is Euthani, Heliki, it's Heliki, or Thessi. There's S-2017 J7, S-2016 J1, S-2017 J3. There's Io Costi. There is S-2003 J16. There's also these named ones called Proxideki, Harpicali, Menimi, Harpini, Thione. Okay, I remember those ones. There's also S-2017 J9. There's Anki, Hersey, Atney, S-2011 J1. There is Kale. Yes, there's a moon called Kale. Taygeti, S-2003 J19. There is Chaladeni. There is S-2003 J10. There's also Ironi, Kalachare, S-2017 J5 and J8. There is Calexi, Carmine, S-2017 J2. Pasithy, S-2010 J1. Ekulade, Archie, Isinone. I'm almost done. We're halfway through. S-2003 J9, J5. S-2017 J6, J5, S-2003 J15, and J23. There's a Dodi, Kalahori, Eurodome, Corin, Silene, S-2011 J2, S-2017 J1, S-2003 J4, Phosphate, Hegelmine, Sinope, Sponde, Autonoli, Megalokite, S-2003 J2. Woo, that is a mouthful for you. Oh, I mean, there are many interesting moons orbiting this planet, but one of the first most scientific interesting ones beyond the 4 moons were, of course, the Galilean satellites. The moons of Jupiter, they're separated into 3 basic groups. These orbit the groups are called inner moons, the Galilean moons, and the outer moons. The inner moons, these orbit closest to Jupiter and are sometimes called the Amathelia group. The names of the inner moons basically are Jupiter are Metis, Adraste, Amathelia, and Thebe. Of course, the Galilean moons, which was discovered by Galileo in 1610, are Europa, Ganymede, and Callisto, the basic four main moons. The outer moons, these are the much smaller and smaller smaller and farther away from Jupiter. Yeah, they're much smaller. Yeah, smurther. Hey, that's a good word. Smurther for smaller and farther away. Smurther. Okay, I'm coining that word, smurther, people. They also have basically irregular and elliptical orbital paths. Of course, many of them are captured asteroids. Let's take a look at some of the inner moons here. Metis. Metis here, it was discovered by Stephen Sinnott. The image is taken through the Voyager 1 probe in 1979. It is the very closest moon to Jupiter. It has a diameter of about 40 kilometers or 25 miles and orbits Jupiter in about, get this, 0.29470 Earth days, which is faster than Jupiter rotates on its own axis. If you guys wonder how these got this name, it was named after the Greek Titaness Metis, who was first wife of the god of the sky Zeus, the first wife. It is thought that this asteroid Metis, it was captured by Jupiter's gravity. The moon basically orbits 79,500 miles from Jupiter, and it has a mass times 1,016 kilograms. I know I'm trying not to be technical for you guys, but I want to let you guys know about some of the moons here. One of the next ones is it's called Adraste. Yes, it's the second closest moon to Jupiter. It has a diameter of about 12 miles and orbits about 80,000 miles from Jupiter itself. This little moonlet right here, it was discovered in 1979 by David Jewett using the Voyager 2. This has a mass of 1.91 by 1,016 kilograms, and it's like Metis, it orbits Jupiter faster than it takes Jupiter to orbit its axis. One of the other inner moons is called Amathea. And on that note, I'm going to take a drink because I should take a drink after I named all of those moons. That was a huge mouthful. Hey, Yvette, how's it going? Sorry. Let's see, who's all in the chat right now? Let's see. Oh, by the way, Vile Mike, you were not the first one. Technically, I was because I pinned a tweet, so ha ha ha. Hey, what's up, Big Fred Entertainment? Oh, Iowa's your favorite? Well, I'm going to get to Iowa in a little bit, Yvette. If you're unable to stay awake because you're across the pond, you can always watch it later, so no offense. I was talking about Adraste when I finally took my drink. Okay. Adraste. It's the third moon from Jupiter, and it's the reddest object in the solar system. It's even redder than Mars. I think it was by a factor of 3. It was discovered by Edwin Emerson Bernard in 1892. Of course, as you can see from the image right here, it's not a spherical moon, but it does have a diameter of about 145 by 91 by 83 miles. It orbits about 112,000 miles from Jupiter itself, and it is located in the faint Gossamer ring of Jupiter. Yes, Jupiter has rings. We talked about on the solar system. Let's see. It takes Amathea about half a day, 12 hours or so, to orbit Jupiter. And of course, like the inner moons, it is tidally locked to the planet. If you do not recall what tidally locked means, it means the same side of the moon always faces the orbiting body, which in this case, it always faces Jupiter. It also gives off more heat than it receives from the sun. I know, interesting, huh? The next inner moon we have is Thebe, or Theb. How do you feel like you want to pronounce it? Theb is the fourth moon from Jupiter. It has a diameter of about 68 by 56 miles, and it orbits about roughly 138,000 miles from Jupiter. It was discovered by Simon Sinnott in 79, and it was officially named Phoebe in 1983. This has it has a mass of 8 by 1017 kilograms. It takes about 0.6745 days of an Earth day to orbit Jupiter. So these are still fairly fast orbiting objects. So let's take a look at some of the 4 prominent moons. The Galilean moons: Io, Europa, Ganymede, and Callisto. Let's see, which moon will Jupiter's station be on? I'm not sure. I did not watch The Expanse. Actually, you can see the rings through certain telescopes. It is very interesting. It's very fascinating, too. And let's talk about the first moon here, Io. Io. It is the innermost Galilean moon with the highest density of all the moons that Jupiter has. So far, scientists have detected over 400 active volcanoes. Yes, I said this correctly. Active volcanoes. It's basically producing sulfur dioxide, resulting from tidal heating within its own interior. I mean, you say Io is your favorite moon. So here's Io. I mean, let me tell you a little bit more about Io here. Io itself, it has over 100 mountains. I mean, some of them are taller than Mount Everest itself. I know, these are very tall mountains here. Some of the analysis, it reveals that the volcanic plumes and lava flows that are responsible for the surface color are different shades of yellow, red, white, black, and green, or as people call it, rotten orange for pizza colors. Atmospheric studies indicate that this has a thin atmosphere consisting of sulfur dioxide, sulfur monoxide, sodium chloride, and atomic sulfur and oxygen. I mean, most of the silicate rocks and iron of Io, most of the rocks based silicate iron rocks of Io. Sorry, let me take another drink again. Excuse me. I'm getting a little ahead of myself here. Oh yeah, I was talking about the air. It's basically a thin atmosphere. Io, has a radius about 1,131 miles and orbits at a distance of 217,000 miles from Jupiter's very top of the clouds. It has a slight ellipsoid-shaped moon, but it also has, get this, an eccentricity of 0.0041 and rotates synchronously with its orbital period, ensuring that one side always is facing Jupiter. I mean, New Horizons basically captured this photograph here, as you can see on the screen right here. Excuse me, somebody's actually knocking at my door for a moment. Enjoy some music. Oh. I apologize about that. My neighbor just decided to be nice and give me some food, so. Okay, we were talking about Io, that's right. Okay. Io is the most volcanic active in the solar system itself, more than Earth. Some of these erupting lava's a fountain dozens of miles high. Io is currently caught in a little tug of war between Jupiter's massive gravity and the smaller but precisely timed poles from 2 neighboring moons that orbit farther from Jupiter, Europa and Ganymede. Like I said before, it's tidally locked. Over 1 point Earth days it takes to rotate once on its axis. and completes one orbit of Jupiter, causing the same side of Io to face always to Jupiter. Like I said, it's highly locked. The atmosphere itself is very thin. It has no moons of its own, but it is possible to have moons. We have not yet discovered that fully yet. And get this, Io has no rings, but it does create a gaseous torus of material along its orbit around Jupiter. Yep, it gets yanked in several sides, you bet. What else was I saying about Io? Let's see. Voyager and Cassini have both flew by Io. Galileo over to Jupiter. Most recently was New Horizons that went to Pluto. They passed by Io as well. They are so active and powerful that these volcanoes can actually be seen with very large telescopes on Earth. You can actually see these for yourself. Europa. Sorry, I'm still talking about Io, ain't I? I'm getting ahead of myself, like I said before. Yeah, I know. Where was I about this? Oh, yeah. Duh. Here it is, Europa. Now I'm getting ahead of myself. Europa is one of my favorite moons of Jupiter because it's a densely ice moon. It has very smooth surfaces. It's one of the smoothest surfaces in our solar system. I have to doubt Commander Riker. It's smoother than an Android's bottom. And do not ask me how I know how smooth an Android's bottom is, okay? The surface of Europa, it's covered with long crisscrossing trackways, as you can see here. But it has very few craters, which means the planet's surface is still active. As scientists estimate, it's about 3.5 to 4.1 billion years ago. Many objects in the solar system were bombarded with asteroids and comets. It's a period known as the heavy lake bombardment. I'll get into that on a future show. Since Europa is so smooth, it's believed that the moon is like the moon. The Earth has been able to recover its surface because it's very actively tidal here. One scientific theory is that Europa contains a large liquid ocean heated by its core beneath the frozen icy shell. Basically, it makes it a world that's possibly sustainable to human life, and I did say possible. Europa, it's a nice little fairly sized moon. It's a little bit smaller than our own moon, our own main moon, because we do have more than one right now, Luna. It's about 2,000 miles across, a diameter of 2,000 miles. It takes about 3.5 days to orbit Jupiter itself. It sits at a distance about 420,000 miles from Jupiter. Basically, it rotates once on its axis and it completes one orbit of Jupiter every 3.5 days. The same side of Europa always faces Jupiter, the reddish bands. This side always faces Jupiter here. Europa has been known to have an extremely thin oxygen atmosphere, which means it's far too thin for humans to breathe. The surface is mainly solid water ice. Of course, it doesn't have any of its own moons. Europa is moonless that we know of, and Europa has no rings. But some moons in the solar system may have rings in the past. We're not exactly sure about this yet. It's been visited by several different spacecraft. And of course, NASA and the ESA and China and Israel have planned to go visit more of our exoplanets, little moons in the future. Besides some of the moons of Saturn here, this moon is very, very, very abundantly full of liquid water. It's one of the best places in the solar system to basically maybe seek potential day of life beyond Earth. We can have a probe there. Like I said, they're going to have future probes drill in, drill out some water. So there's nothing spewing out. But as you can see right here with the stripes, the image on the left-hand side, yeah, I'll make it a little easier for you guys to see. The image on the left side shows a rain of Europa's crust, made of entirely blocks which are thought to have broken apart and quote-unquote rafted into new positions. These features are the best geological evidence to date that Europa may have had a subsurface ocean at some time in its own past. Combined with the geological data, the presence of a magnetic field, it leads scientists to believe that an ocean is most likely present at Europa today. As you can see in this false color image, the reddish-brown areas, they represent non-mature resulting from geological activity. Of course, while areas are raised of material ejected during the formation of the 25-kilometer diameter impact crater, Pwyll, Pwyll, in case you guys want to know what it's spelled. Icy plains here, they're shown in blue tones, basically to distinguish possible coarse-grained ice. Dark blue from fine-grained ice, light blue. The long, dark lines, they are ridges and fractures in the crust. Some of these ridges and fractures, they're more than 3,000 kilometers long. That's about 2,000 miles. These images here were obtained by Galileo in 1996 and 97. Yeah, life not yet. One of the next moons here is called Ganymede. Ganymede here is the largest moon in our own solar system. It's the only moon with its own magnetic field. Interesting, huh? The magnetic field course auroras, because of the auroras, which basically they're ribbons of glowing electrical gas. We see them on the north and southern poles here, and on Jupiter and Saturn as well. Ganymede. Oh no, you're nodding off. I'm not that boring, am I? No, I'm just kidding with you. I know you're across the pond. Let's see, what was I talking about? Oh yeah, I was talking about Ganymede. Ganymede has large, bright rains or ridges and grooves that slice across older, darker terrains. I mean, these grooved regions, they're clues that the moon experienced dramatic upheavals in the distant past. Scientists have also found strong evidence of an underground ocean on Ganymede. Ganymede, it has three main layers. Yes, it has a sphere of metallic iron at its center, the core, which basically generates a magnetic field, a spherical shell of rock surrounding the ice core, and a spherical shell of mostly ice surrounding the rock shell and the core itself. Scientists have measured this, and the ice shell on the outside of it is probably about 500 miles thick. That's what they're estimating it to be. The surface itself is very top on the ice shelf. Of course, it's mostly ice. The ice shell may contain some rock mixed into it. Scientists also believe that there may be some fair amount of rock in the ice near the surface. As you guys may know, that Ganymede's magnetic field itself is embedded inside Jupiter's mass magnetosphere. Hey, Corin.
What's happening? This is Corin, Nemic. I'm talking to you from my backyard. Just signed up for Cameo after Sean asked and told me that's what all the cool kids are doing. So I'm just trying to be one of the cool kids. But I am dedicated to this. Dedicated to leaving you a message, no matter what the conditions are. That's why I'm doing this in the rain, to prove to you how serious I am about this. I mean, I will give you a shout out from a train. I'll give a shout out to you while I'm on a plane. I'll give a shout out to you from a car. I'll give a shout out to you from a dive bar. In fact, I heard that David Faustino's on here as well. He said that he was going to give some weird and creepy shout outs, but I challenge him. You want a weird and creepy shout out? Came to the right place, buddy.
Corin, get out, man. Jeez, I'm talking about Ganymede. Listen, if you guys, obviously, Corin never keeps on interrupting my show because not enough people are booking a cameo with him. So if you guys want to book a cameo, the information's down on the bottom of the show. So please book a cameo with Corin Nemic. Maybe he'll stop interrupting my show, man. I'm talking science here. Oi, okay, Ganymede. We are talking about Ganymede here. Oh. Astronomers using the Hubble telescope found evidence of a thin oxygen atmosphere on Ganymede in 1996. Of course, like I said, this atmosphere is far too thin to support any life as we know it. As we know it. In 2004, scientists actually discovered irregular lumps beneath the icy surface of Ganymede. The irregular mass may be rock formations supported by Ganymede's ice shells for billions of years. This tells scientists that the ice is probably strong enough, or at least near the surface, to support these possible rock masses from sinking to the bottom of the thin ice. However, this anomaly can also be caused by a pile of rocks at the bottom of the ice. Funny comment here, Mr. Miles. Which moon contains time crystals? I'm not sure. You have to ask the doctor for that. I'm not privy to that information. Ganymede, the inside of Ganymede. Spacecraft images of Ganymede, basically it shows the moon has a complex geological history. Ganymede's surface is a mixture of two types of terrain. 40% of the surface of Ganymede is covered by a highly cratered dark region, and the remaining 60% is basically covered by a light grooved terrain, which forms intricate patterns all across the surface of the planet. The term quote-unquote succulus, meaning a groove or burrow, it is often used to describe the grooved features. The grooved terrain is probably formed by tensional faulting or the release of water from the surface. Groove ridges are basically about high as 2,000 feet. They have been observed, and the grooves run from thousands of kilometers across the surface of the moon. Oh, these grooves, they have a relatively few craters and basically probably developed in the expanse of the darker crust. The dark rings of Ganymede, they are old and rough, and the dark crater terrain is believed to be the original crust of the satellite itself. Lighter rains are young and smooth, unlike our own moon here. The largest area of Ganymede is called the Galileo Regio. The largest craters in Ganymede have almost no vertical relief and are quite flat. They basically lack a central depression common to craters often seen on rocky surfaces. The scientists believe this is probably due to slow and gradual adjustments to soft the ice surface. Yeah, that's their best explanation I could think of this. Okay. The large phantom craters are called, get this, palpacetus. It's a term originally applied to reuse ancient writing materials on which older writing was still visible underneath newer writing. These palpacetus, they range from about 40 to 400 kilometers in diameter itself. We don't know what the version of these moons. Well, I'm going to put the little information in the chat itself at the end of the show here, so you guys can actually check this out. About some of these scientist theories about formation of the moons. The next moon that I have right here to talk about is called Callisto. It's not a dance. Well, it could be a dance, but it's also a moon. This is the 8th moon of Jupiter, and it's the second largest moon of Jupiter known. It's the 3rd largest moon in our own solar system, and it's about the same size as Mercury. Callisto itself, is the 8th moon of Jupiter and is large, dark, but low density moon, which is covered with impact craters. It is home to the famous Valhalla crater, which is nearly 4,000 kilometers wide. And by the way, it is the largest crater in our own solar system. So Jupiter has another record. Yay! Basically, it's only about 1.2 miles orbiting from Jupiter. It's relatively close, so medium range, so medium close if you want to go astronomical terms. It only takes about 16 and a half days to complete an orbit around Jupiter. Of course, during that time, it will have to travel more than 7 million miles. Callisto has about 99% of the diameter of the planet Mercury, but only 1/3 of the mass. I know. Some of our moons are weird. The moon Callisto itself, it's made of about 60% rock iron and 40% ice, and it also may contain a liquid ocean. Check out this diagram here. Callisto, What's that? So, is Pluto a planet? It's a Plutoid. Pluto is a Plutoid. That's what I still say. Pluto is a Plutoid. It's not a planet. It's not a dwarf planet. It's a Plutoid. Just have its own distinguishable names. But Callisto is not a Plutoid. It's a moon. It's both composed of rock and ice, about 60-40%. So there are also traces of water ice, carbon dioxide, silicates, and organic compounds found on the surface. The Galileo spacecraft also revealed that the moon may have a subsurface ocean, which is about 100 kilometers or more below the surface. Callisto itself, it's not really affected by other little moons, but it's not even affected by the gravity of Jupiter. Basically, let me say that again. Callisto is not affected by the gravity of other moons of Jupiter. Yeah. Because unlike Io, Europa, and Ganymede, Callisto doesn't suffer from an orbital gravitational pull. Yep, you heard me say that. It does not suffer from a gravitational orbital pull. But basically it means there's less of a tidal heating inside. A buildup of friction, orbital, and rotational energy that are dissipated as heat in the crust of the moons and the planets involved, which basically caused the melting of the surface ice from the rocky mantle of the Europa moon, for example. The reason it is less affected by Jupiter's magnetosphere is that it orbits farther away from the planets. Callisto is over 1 million miles away from Jupiter. It orbits about 238,000 miles from us. Earth orbits about 238,000 miles from us. Callisto's orbit Jupiter at an average of a distance of 1.6 million miles, or 1.82 million kilometers. It takes about 16 and a half days, I said, of the orbit. So, there are some other moons besides Callisto. There is also Leda. Leda is the ninth moon from Jupiter. It's also one of the smallest moons with a mean diameter of 16 kilometers. It was discovered in 1974 by Charles Corin. There is also Himalaya. It's Jupiter's 10th moon. It was discovered by Charles Perny in 1904. There was Lastia, the 11th moon. It's only about 24 kilometers in diameter. It's about 11,720,000 kilometers from Jupiter. Alera, it was discovered in 1905 by Charles Perny. It's Jupiter's 12th moon. It only has a diameter of about 50 miles. There's also Anki, Jupiter's 13th moon. It was discovered in 1951 by Seth Nicholson. Anki has a diameter of about 20 kilometers and orbits about 21 million kilometers away from Jupiter. There is Carmine, discovered in 1938 by Charles Nicholson. It's the 14th moon of Jupiter. There is Phosphate, the 15th moon of Jupiter, discovered by P. Melolte in 1908. It only orbits at about 14 million miles from Jupiter. There is Sinope, Jupiter's 16th moon, discovered by 1940 by Seth Nicholson. It's a very small little moon. It only is about 17.5 miles in diameter, but it orbits about 14 million miles away from Jupiter. There is Kalahari. Jupiter's 17th confirmed moon was Kalahari. It used to be known as S-1919, but it was discovered by Timothy Safar on July 18, 2000. It has a diameter of about 5.5 miles and orbits Jupiter about 15 million miles away. So that is pretty far. Did you guys know that Earth is not the only place with water? Nope. There is liquid water on other bodies of our solar system besides Earth. As you can see a little diagram right here. Let me expand this little diagram for you. It's pretty cool. We have, of course, water. Enceladus, Earth, Europa, Triton, Ganymede, Callisto. Well, the proposed ones are Triton and Callisto. They're actually sure, but Ganymede, Enceladus, Earth, Europa, and Titan all has liquid surfaces on its body. The only difference is Titan's liquid surface is methane, not water. And there is some news in Jupiter here. Yes, there is news of Jupiter. There is. Let me do this in a second. This is the active world right here. If you guys want to actually check or pause the screen while you're watching this replay, I found a little chart here about active worlds of our moons. It describes the difference between Io, Europa, Enceladus, and Titan. There is a new discovery of Jupiter. Its moon called S-216J2, Valitudo. This tiny moon of Jupiter was first spotted in 2017, but the announcement wasn't made until July 2018. And yes, this was an accidental discovery because some scientists, led by Scott Shepard from the Carnegie Institute for Science, he was looking for the quote-unquote proposed planet 9 and accidentally found 12 moons orbiting Jupiter. Yes, I know. What an oops accidental discovery. He said that, where's his quote? Of the 12 moon discoveries, 11 are normal, quote unquote. For the 12th moon, however, is discovered as a riddle or oddball. Because of the unique orbit and because it's also probably Jupiter's smallest known moon, at least a kilometer in diameter, this newly discovered oddball moon, it has a prograde orbit, but it orbits farther from Jupiter than any other moons, and in the larger prograde group, it takes about 1.5 Earth years to complete an orbit. I mean, this satellite's oddness, it comes from its tiny size and the fact that, although it's out in the realm of the retrograde moons, it's orbiting in the opposite direction to them. Yeah, it's going backwards. Researchers have proposed naming the oddball Valatu, the Roman goddess of health and hygiene. It's more just an odd moon, though. It's a hazard out there. Because it's orbiting in the opposite direction of the 9 new retrograde moons and across their paths, there's a high risk that it will hit one of them, according to the statement that Shepard said. He said, quote, "This is an unstable situation." Quote, head-on collisions would quickly break apart and grind objects down to dust. Yeah. I mean, some of these Jupiter's moons and moon groupings, including the oddball, could have formed from collisions like this, according to his statements. I'm going to put that, like you asked, how do the moons form? I told you. I'm going to include this in the end of this broadcast here. And listen, I want to thank everybody here for coming to join me as we explore some of Jupiter's moons. Next week on February 10th, Wednesday, 12 noon, we are going to be having a show about impacts. Yes, asteroid impacts and the cause they have on our solar system. Yes, exciting and interesting and fun. Oh, let's see. We have a question here. I forgot about this one. If Pluto was not in orbit around Jupiter, would it be a moon? If it was in orbit around Jupiter, yes, it would be a moon if it was technically followed its path and did not actually disintegrate into its orbit. It has to be captured by Jupiter's gravity, be considered a moon. Like we have our own little second moon that's captured by Earth's gravity, but it will eventually get pushed away because the interaction of our own moon and Earth will gravitationally pull it away. Like I said, these planets are orbitally locked, except for that last one moon, which goes backwards. Oops, wrong button here. Hey, I'm on the wrong button here. I want to thank everybody joining me today. People who hopped in on the chat today. Well, a little early. Mike, Yvette, Biggerford Entertainment, Jason, Tucker Statement, Averick Sonder. Welcome, Captain Trek, Kai and FS. Welcome, everybody else who is watching this show on a repeat, or you happen to watch this live or rerun, or if you want to know what's up with the universe. So I want to thank everybody for coming, and you guys have a good night, okay?